This video is on relations and functions. A relation is a set of ordered pairs, typically denoted by x, y. If you watched the previous video on graphing relationships, we had a problem that we drew a graph for that was about what hour it is and the number of hot dogs you've eaten. We also had a problem where time is passing and someone's filling a swimming pool and measuring the water level. And then we also had one where each day the number of visitors to a park is counted. So these are all examples of relations. So you have two variables and they're connected by something. All right, here's an example involving track meet scoring. At this particular track meet, first place earns 5 points for your team. A second place finish earns 3 points for your team. A third place finish earns 2 points for your team. And a fourth place finish earns 1 point for your team. This is a set of ordered pairs. The first number is the place that you finish, and the second number is the number of points you've earned for your team. So this is place versus points. So that's a relation. Now we're going to look at this particular set of ordered pairs using 3 different structures. We're going to use a table, we're going to use a graph, and we're going to use what's called a mapping diagram. A table refers to a table of values. You may recognize this from pre-algebra. In the first column, you have the first variable, which in this case is place, and the second column in this case is points. There are 4 different places which earn points. First place earns 5 points, second place 3, third place 2, and fourth place 1. This is called a table of values. Typically, we call the first variable x and the second variable y, and the numbers in the columns are the values that those variables are taking. A graph is constructed to kind of show a picture of the relation. Graphs make it easier to see things like trends, like up, down, increase, decrease, high, low. You typically put x on the horizontal axis and y on the vertical axis. So in this particular problem, my x-axis is labeled place and my vertical axis is labeled points. There are 4 places which earn points. Notice how I've equally spaced them. So if you look here, there's 3 squares, 3, 3, 3 here. And we have different points available, and we have to go from 1 to 5. Now we can't skip 4 even though it's not in the set. So we're going to go 1 point, 2 point, 3 points, 4 points, 5 points. So these have to be equally spaced and the numbers have to be consecutive. You can't skip any numbers. Alright, first place earns 5 points. So what I'll do is I'll just kind of go up from 1 and over from 5, and I'll put a dot, and there's my ordered pair. Second place earns 3 points. Third place earns 2 points, and fourth place earns 1 point. Now you can see by looking at the graph that there's this gap right here because there's no value at 4. We can also see as the place gets worse, meaning a bigger number, fourth place is lower, in points than first place. This is trending down. In the mapping diagram, you have an oval or a circle or a bubble that represents the first variable, place, and another one that represents the second variable, in this case, points. Now, it doesn't matter where you put the numbers in these bubbles, but you only want to put the numbers you need. Okay, that's a difference from the graph. So in points, I'm going to put 1, 2, 3, and 5. Most important for the mapping diagram is that you connect first place with 5 points, second place with 3 points, third place with 2 points, and fourth place with 1 point. So these are sort of called the maps. We would say that 1 is mapped to 5, 2 is mapped to 3, and so on. Notice again that place is X and points is Y. Now, the set of first coordinates, called X in each of these examples, has a special name called the domain. So let's write down domain, and this is the set of first coordinates. And it's not, it would be fine to think of it as the set of x's, honestly. Even though we don't always use x and y as our variables, it's the set of x's. The set of y values, the second column of the table, is called the range. So this is the set of second coordinates, or the set of y values, the set of y's. So in this particular example, our domain, if we're asked to write it, consists of the numbers 1, 2, 3, and 4. Now, you are supposed to use these curvy, they're called braces typically. And if you just do like a squiggle, if they're hard for you to draw, just do it like a little squiggle down the paper. It is very important though that you use those, something to indicate that squiggle. That's set notation in mathematics. Now I want you to notice that I wrote these numbers in order, 1, 2, 3, 4. This is very important. The range for the track meet problem is 1, 2, 3, 5. Again, notice the braces. Also notice I didn't write a 4 in there. The domain is the set of first coordinates. It's only the numbers in the problem. And the range is the set of second coordinates, only the numbers in the problem. All right, let's look at another example. Notice the set brace. And then we have 1, negative 1. We have 1, positive 1. 4, negative 2. 4 and 2. 9 and 3. And 9 and negative 3. This is a set of ordered pairs, so it's a relation. That's the very definition of a relation. 1 is related to negative 1. 1 is related also to 1. 4 is related to negative 2. 4 is also related to positive 2, and so on. The domain for this relation is the set of first coordinates. I'm going to underline them with red. Now notice that 1 occurs twice, 4 occurs twice, and 9 occurs twice. When you write the domain, though, you only put the numbers. You don't repeat. So don't write the 1 twice just because it's in 2 ordered pairs, because 1 is 1. It's a single number. The range is the set of second coordinates, I'll underline those with green. Now, these don't repeat at all. Now, you could probably get away sometimes with not doing this, but you really ought to put the numbers in order. So the numbers in the set are -1, 1, -2, 2, 3, -3. We want to put the smallest number first. So which of those numbers is smallest? So think about money, and negatives mean debt. The worst possible place you can be in is to owe somebody $3 for this particular problem. So -3 is first, then we would put -2, then -1, and then the positive numbers, +1, +2, and +3. So notice both of these set, I've ordered the numbers. Order the numbers, small to large. Your teachers will be happier with you if you follow that convention. Okay, let me erase this. All right, this brings us to the word function. Functions are extremely important in algebra. A function is a special type of relation where each x is paired with exactly one y. That's a function. So we're going to look back up at our first example. If I can scroll, I want you to look at these set of numbers. If I were to ask you, how many points does a first place person get? You would tell me 5. If I said, how many points does a second place person get? You would tell me 3. Third place gets 2. Fourth place gets 1. There's no ambiguity about that. Each x gets exactly 1y. That's a function. But now let's go down to this next example. If I were to ask you, let me use the rainbow. If I were to ask you, what number is paired with 1? You would say -1, oh, or +1. The fact that there are 2 answers when I ask you for 1's partner means this is not a function. 1 is paired with 2 different numbers. 4 also is paired with 2 different numbers, and so is 9. So this is not a function, so it's a relation, not a function. Okay, so each x is paired with only one y. Let's take a look at functions versus non-functions by looking at tables, graphs, and mapping diagrams. So we're going to make a table. I made partway through this video a few minutes ago, it shut down on me, and so I thought I lost all my notes. Apparently I didn't. Okay, here we go. So our headings, we're going to have a column of relations which are not functions, and then we're going to have a column which are functions. And first we're going to look at the table of values. In the example above, 1 was paired with -1, and 1 was also paired with 1. 4 was paired with -2, 4 was also paired with 2. 9 was paired with -3, and 9 was also paired with 3. Notice how the x values repeat. Not every x value has to repeat. It only takes one x value repeating, and you are not dealing with a function. So x repeats. So if you're looking at a table of values and you see the same number more than once for x, this is not a function. Immediately you know that. All right, for a function, we'll use our track meet numbers. Notice there are no repeats. Okay, so we can recognize that this second table is the table of a function. All right, next we're going to look at the graph. Now this is an interesting graph. We care about the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. You could label all of those tick marks. I only want to label those. I will put the marks though. There we go. And then our range, our y values were 1 and -1, 2 and -2, and 3 and -3. 1 was paired with both 1 and -1. 4 was paired with 2 and -2. 9 was paired with 3 and -3. So this is not a function. If you see a vertical stack of dots, it only takes one vertical stack of dots and it's not a function. See this light blue vertical line I've dotted in? There are 2 points on that line. So this is called the vertical line test. You can only have 1 point per line, so this is not a function. All right, now let's look at the graph of a function. We have first place, second place, third place, fourth place. And we have 1, 2, 3, 4, 5 points possible. We have first place with 5 points, second place with 3 points, third with 2 points, and fourth with 1 point. Notice, if I were to draw a vertical line, 1 dot, 1 dot, 1 dot, 1 dot, that's called passing the vertical line test. So this one passes the VLT. So it's a function. And let me just write, since you can't see the heading anymore, not a function over here. Vertical line test failed. All right, and last, we're going to look at the mapping diagram. Bubble, bubble. Okay, the numbers in the domain for this example were what? 1, 4, and 9. The numbers in the range were 1, -1, 2, -2, 3, -3. Order doesn't matter. 1 is mapped to both 1 and -1, 4 is mapped to 2 and -2, 9 is mapped to 3 and -3. When you see lines coming from the same number from left to right, here's the left side, here's the right side, when you see this, so think of it as a mouth. when you see it going from left to right, so the thing on the right is being eaten by the mouth. This is not a function. Not a function. When you look at the mapping diagram for the track meet problem, first place, second place, third place, fourth place, 1 point, 2 point, 3 point, 5 point. Don't forget your maps. 1 is with 5, 2 is with 3, 3 is with 2, 4 is with 1. Notice that each of these has only one line coming out. This is a function, and that's how you recognize it in a mapping diagram. I want you to notice another thing with respect to domain and range. Take a look at the domain in this first column. The domain is 149. When you look at the range, you're going to notice something. -3, -2, -1, 1, 2, 3. Look how much bigger the range is than the domain. If your range is bigger than your domain, you are not dealing with a function, because that means those domain guys have to partner up with more than one guy in the other set. So, different size, domain and range. Okay, we're going to just do a few examples of graphs, and then we'll be done. What do we want to call this? We'll just call it graphs. Our first graph is going to be a circle. 1, 2, 3, 4, 5. Alright, pretend this looks good. Oh, that's really bad. Sorry. Okay, so the domain of this circle. Remember, domain is the set of first coordinates, so it's going from left to right. This is left, this is right. The number on the left is -1, -2, -3, -4. The number on the right is +3. So the domain is from -4 to +3. We're not going to use fancy notation for that right now. The range for this circle, let's say it goes all the way down to the 0. The range is from bottom to top. So the bottom's at 0, and the top is, let's count, 1, 2, 3, 4, 5, 6. So the range is 0 to 6. Question, is this a function? Is it a function? Let's put a function with a question mark. Well, draw a vertical line. Are there 2 points on the circle on that same vertical line? There are. See that? So this is not a function. Okay, let's look at another graph. I'm trying to draw some strange graphs for you. This is 10, 20, 30, and let's say this graph is just a vertical line right at 20. Right here. There's my graph. And let's say this value right here, this high point, is at 100. Here's 0. Okay, the domain of this graph is the set of first coordinates. What do you notice about every single x value for every single point on this line? Every single x value is 20. The domain for this graph is 20. The range for this graph, well, bottom is 0 and the top is 100. So the range is from 0 to 100. And is that a function? Well, it's a vertical line. And there are tons of dots on that vertical line. so it is not a function. Okay, we're going to look at another graph. Just going to do a little line segment here. We'll start the line segment right here, and we'll end it right there. Okay. Well, this is, let's see, -1, -2, and 1, 2, 3, 4, 5. And going left, I go to -2, going right, 1, 2, 3, 4. So the domain is from left to right. The left is here at -2. The right is here at 4. So that goes from -2 to 4. The range is from bottom to top. The bottom of this graph, the bottom is at -2. The top of the graph is at 5. Is this a function? Well, let's do some vertical lines. Just visualize vertical lines. Each one of those vertical lines only touches that blue line one time. So yes, this is a function. Func. Alright, I'm going to teach you a little trick for finding domain and range. Suppose I have, let's see, I'm going to curve this thing. It's going to go like this, and then down here. Okay. And we want to look at the domain and range. So let's figure out some numbers here. -1, -2, -3. This is -4. +1, 2, 3, 4, 5, 6, 7. That's 7. 1, 2, -3. 1, 2, 3, 4, 5, 6. What we're going to do is we're going to put a box, a perfectly sized box for this. You're going to ship this to your friend. So we're going to draw a box that just perfectly fits the shape. And there's no wiggle room. Now, the left side of the box, left, to the right side of the box is the domain. So the domain for this function is -4 to +7. The range, well, is the bottom. This is the bottom of the box. This is the top of the box. So the range is from the bottom, which is at -3, all the way up to the top, which is at 6. So build a box if you need help identifying domain and range. There's a lot more to functions. We'll be learning more as we go through more videos. So this is a video on relations and functions. Thank you for watching.